Good morning. Earlier, I discussed the topic related to air and ventilation. In this part of the course, we will get acquainted with the ventilation project, legal requirements, provisions in the Polish standard, as well as other technical guidelines regarding the installation of the entire air distribution system and the heat recovery unit itself. Ventilation and heat recovery system in a single-family house. Its primary task is to exchange used, polluted air for outside air, which should be pre-cleaned, that is, filtered, and have the same parameters as the outdoor air, meaning the same carbon dioxide concentration, humidity, and temperature. But for this to happen, the installation must be properly designed, and then, in the next stage, it must be executed. And starting with the design, we create projects for specific clients. As Peflex, we prepare designs for investors, installers, architects, or construction companies. So in fact, all people involved and in some way interested in the topic of recuperation can definitely benefit from this part, related to the project itself. How to order. How to obtain such a project, i.e. order it on the website. The principle is simple. You go to the site, choose the appropriate project depending on the building's area, and the fee for the project will also depend on that. Then, after payment, yes, we send all the technical documentation to the email address project@peflex.pl. We wait to be contacted by the assigned designer. We receive a preliminary version of the project. After approval, we get the finalized part. Types of projects available on cynic24.pl. These are the recuperation project and the technical recuperation project. According to the building law that has been enforced since January of last year, to obtain a permit for building occupancy, technical projects and the rest of the documents are required, so this technical project is actually required from the very first day of construction as well. This is a technical project not only for the recuperation system itself, but also for other installations like water, heating, and electricity. But as I mentioned, our offer includes a technical recuperation project. In terms of calculations, the technical project does not differ from the technical project from the recuperation project. The only and main difference is that the technical project is certified by a person authorized to prepare technical designs. There are also versions available. The standard completion time for such a project, a recuperation project, is 7 days. There is also an express version available, completed within 2 days. In the case where, for some reason, someone decides to install recuperation in a building, and for example, in 2, 3, or 4 days, the pouring of the ceilings is planned, so to leave the right spaces for passages, for transitions, under the ducts from the boxes, you can also choose this express version. Okay, what information do we need, or do the designers need, to create such a project? First and foremost, it's the architectural design of the building, meaning the floor plans with information marked about the purpose of the rooms, their sizes, but also, ideally, if a cross-section of the building is also provided. And we also ask for a completed form with additional questions, because it's the investor or the installer commissioning the project who knows where the space is planned for the installation to be distributed. Depending on whether it's along the floor, within the layer of acoustic insulation, or suspended in the ceiling, above the ceiling, or in the space of a suspended ceiling. Such information is necessary for the designer to properly plan and distribute the installation inside the building. Along with the design, that is, in the project, yes, a technical description is provided, a technical description and information about the materials used. What kind of ducts, filters, the location of the ventilation unit, or specifically where the system is routed, whether it's along the floor or in the space of a suspended ceiling, so this description is included in the design section. But moving on to the calculation part. The first thing we really need to do is calculate how many cubic meters of air should flow through the building, and we also calculate or initially estimate the resistance that the given installation will create. Why am I talking about this resistance? Because the information about the resistance in the installation will be necessary for us to properly select the ventilation unit. But starting with filling out this table, where we have the rooms listed: living room, bedroom, kitchen, bathroom, toilet, and the corresponding values, the numbers assigned in the supply and exhaust columns. To do this correctly, we need to refer to the laws in force in our country, and the fundamental law concerning the entire building process is the technical conditions, or in other words, the regulation of the Minister of Infrastructure regarding the technical conditions that buildings and their location should meet. So, taking into account this first document, that is, the regulation in which we have the basic information regarding the amount of air supplied to the building, we mainly supply air to rooms where people are present. Because in those places we need to ensure proper conditions, meaning the right concentration of carbon dioxide and the right concentration of oxygen. So, taking into account the regulation of the Minister of Infrastructure, the regulation regarding technical conditions, we have paragraph 141.1, which states that the flow of outside air supplied to rooms that are not workspaces should be based on the flow of exhaust air in accordance with the applicable Polish standard, but not less than 20 cubic meters of air per hour per person expected to stay permanently, as specified in the construction project. But what does that mean for us? So again, referring to paragraph 4 of this regulation, rooms intended for human occupancy are divided into rooms for permanent stay and rooms for temporary stay. Rooms for permanent stay are those where people can stay for more than 4 hours a day, so a bedroom is definitely such a room, but a living room can also be considered as one. I don't know, perhaps a dedicated dining room complete with a small kitchenette, or indeed any suitable place where individuals who are intended for a permanent stay within the building's design can comfortably spend more than just those 4 hours during the course of the day. So, taking into account the minimum airflow specified in the regulation, which is 20 cubic meters, and considering a sample project where we have 2 plus 2, that is, 2 adults plus 2 children, so there are 4 people in the bedrooms, but these 4 people can also be in the living room. So one solution could be that this air supplied to the building. So that's definitely 4 times 20. And now we can calculate it, related to the exhaust air stream, or we can also assume that we supply 4 times 20 to the living room as well, meaning that the minimum airflow will be 160 cubic meters. However, taking into account human physiology or physiognomy, we function properly when the concentration of carbon dioxide in a room is within the range between what is outside, background level, 450, 500 ppm, up to 1000 ppm. So, considering the need to maintain this level of air quality, that is, below 1000 ppm, the minimum airflow required per person is 10 liters per second. When you convert that to cubic meters, it comes out to 36 cubic meters of air per hour. So, the regulations tell us the minimum is 20, but the optimal solution would be 36 or even 40. So, taking into account the number of people in the building, that is, 4 times the number of people, let's say times 2 more considering the living room, then we have 8 times 36, which gives us 288 cubic meters of air per hour. That's the airflow. So, we have a range between 160 and 288 cubic meters. That's how much air we need to supply to the building, both due to the regulations and for our own well-being and physiology. However, these technical regulations refer to the Polish standard PN 83/B03430 with the amendment from the year 2000, where the airflow rates for air removed from hygienic and sanitary rooms are specified. Such rooms include the kitchen, bathroom, toilet, and windowless rooms. And now, depending on the type of kitchen, whether the heat source or appliance is an electric or gas stove, in such a room, we need to extract between 30 and 70 cubic meters of air per hour. When it comes to the bathroom, where the main goal is to remove excess moisture, that's 50 cubic meters. A toilet or WC room requires 30 cubic meters. A windowless room needs 15 cubic meters. As I mentioned, such a room could be an entryway, a pantry, or a walk-in closet. So, Taking into account the nature of these rooms in the building for this sample project, the minimum airflow we need to extract according to the Polish standard is 230 cubic meters of air. And the third method, right? Which is also possible, but let's treat it as, a quick engineering method, just to estimate the size of the ventilation airflow, that is, based on the room volume. The Polish standard includes a provision regarding the exchange of at least one air volume per hour in a given room, one room volume. But this provision applies to residential spaces or collective residential buildings, such as hotels, hostels, or guest houses. So there is no legal reference for this, right? For this application. However, as I mentioned, this method, meaning by room volume, is very often used, right? Among installers, among investors, as a way of asking, right? How to select a recuperation system. So if we were to use this volume-based method in any way, here the coefficients range from 0.42, where 0.42 means air exchanges, right? The building's total volume is a coefficient recommended by the Eurovent Association, that is, the European Ventilation Association, up to, let's say, 0.8 of the volume value. However, as I said, if someone wants to make a quick estimate, the best solution is to multiply by 0.5, so simply divide by 2. For this particular example, we have values ranging from 180 to 344 cubic meters of air. So now, having these three options, two based on the law and the third being a generally accepted engineering method, we're operating between 230 and 344 cubic meters of air per hour. Taking into account the number of people in the building, the optimal solution would be 288 cubic meters of air. It's also important to remember that the main task of the ventilation system is to exchange and maintain proper air quality, but in a way that doesn't disturb the people living in the house. Here I'm talking specifically about noise, because if we design the system so that the air speed is too high, that is, above 3 cubic meters, above 3 meters per second in those semi-flexible ducts, meaning between the manifold and the plenum box, then the system will be noisy. So, when considering parameters related to efficiency and airflow, you also need to take into account this additional parameter related to noise. Because even if we deliver the correct amount of air in cubic meters, but the system is noisy, then I suspect that 99% of the time, the user of the building will simply turn it off or reduce the airflow. So the system will be, let's call it, quiet or comfortable in terms of noise, but again, in terms of the amount of cubic meters of air, it won't fulfill its basic function, so you could say it was poorly executed and poorly designed. In the design, we receive a diagram of the installation, meaning a layout of the individual ducts, for example, from the distribution box to the living room or to the bedroom, or from the distribution box to so-called dirty rooms like the kitchen, bathroom, or toilet. And depending on the airflow, on the capacity, we select the number of ventilation ducts according to their diameter and capacity so that, in the end, at this supply point or at this exhaust point, we achieve the desired airflow. The connection of the ventilation unit to the air intake and exhaust is also drawn out, as well as the connection to the distribution boxes, to the supply air distributor, and the exhaust air distributor. Here's another example of how it's prepared right away. Meanwhile, on the CNIC24.pl website, in the Projects tab, there are examples of completed projects available, so you can download such an example and familiarize yourself with its contents and the way it is, marked and drawn on the sketch, so you can check and see if it's what suits and fits your needs. The topic of the next part is, where can ventilation ducts be installed? The floor? The ceiling? Or maybe somewhere else?